Good day, everyone. Welcome to the 33rd monthly talk of Balaraman Science Forum. Carl Sagan said, "We live in a society exclusively dependent on science and technology, in which hardly anyone knows anything about."
Go on.
We live in a society exclusively dependent on science and technology, in which hardly anyone knows anything about science and technology, said Carl Sagan. In close to 25 years since he passed away, the dependency has only increased. It became imperative that we, the common citizens, are familiar with science and technology. Balaraman Science Forum's goal is to take science and technology to the common folks. We have had speakers who are professionals and had speakers who are science enthusiasts. And these people have spoken on a heterogeneous collection of topics. If you have an interesting topic that can kindle the audience curiosity and make them want to learn more, please do approach us via our FB page or email ID. Now on to today's topic. What is this thing called artificial intelligence? Didn't an AI engine beat Kasparov in the 90s? Why are we talking about AI as if it is something new? Do we use AI in our daily life? Why should we learn about AI? Is AI a single technology or a basket of technologies? Is machine intelligence the same as human intelligence? Will AI take over humans? Should we be excited? Should we be happy, or should we be deeply worried about it? What is the impact of AI on traditional job markets as we know it today? This talk will help you answer these queries and a lot more. If you have any queries to ask, please share it on YouTube feed or WhatsApp group. We will try to get them answered at the end of the session. Now, on to introducing today's speaker, Professor Ravindran. Professor Ravindran Balaraman, he heads the Robert Bosch Centre of Data Science and Artificial Intelligence at IIT Madras. It's a leading interdisciplinary AI research center in India. He is the Mindtree Faculty Fellow and Professor in the Department of Computer Science and Engineering at IIT Madras. He has held visiting positions at Indian Institute of Science, Bangalore, and University of Technology, Sydney. He is among the leading experts in AI in the country and advises the Indian government on several initiatives related to AI and data science. He received his PhD from the University of Massachusetts, AMS, and his master's degree from Indian Institute of Science, Bangalore. He has more than 2 decades of research experience in AI, ML, and specifically reinforcement learning. Currently, his research interests span the areas of social network analysis, geometric deep learning, and reinforcement learning. He has been closely collaborating with the various industrial research labs such as Google Research, Intel Research, Ericsson R&D, working on applications of AI techniques to hard real-world problems. He also serves as a consultant to many startups in this space. Thanks for agreeing to give this talk, Professor Ravindran. Over to you.
Sorry, it appears I was muted. So thank you, Ramana, and thank you, Popu and Patni, for giving me this opportunity to talk at the Ravindran Science Forum. And I have been attending several talks in the past, and I had never worked up enough courage to volunteer to do one until now. So let's see how this goes. So the title of my presentation is "What is this thing called AI?" And so let me make it very clear up front that this is not a tutorial on AI. So I don't expect people to walk away from this talk knowing what AI is or building the next big AI application. But it's basically to give you a very, very simple view of what is AI and what it can do, what it can't do. And so let me start off with this question. Is this AI? So this might seem laughable to some of you, but in reality, there is a story behind this. So one of our neighbors, she's close to 80, asked my mother one day, hey, I keep hearing this thing called AI, AI. What is it? Is it like the Pushpaka Vimanam of Rome? Is that what AI is? So there are two things to take away from this. First thing is an 8-year-old has heard of AI. She's curious to learn more. And the second thing is there is really rampant ignorance about what AI is. So here is a one slide takeaway from the talk. You're not going to listen to the rest of the talk. Just remember this. AI is a piece of software. So AI is not magic. Right? So AI is not something that's going to miraculously solve your problem. AI is not a connection. It's a piece of software, and you use it as you would use it. AI is everything. Right? So we are seeing this whenever you fire off a Google search, there's a lot of AI that runs behind it. Particularly when you're talking about these kinds of info boxes that come up in Google search, there's a lot of very very high end AI technology play there, right? Or you use Facebook and then you get these boxes popping up and asking you to name the person in your photographs, right? So that is AI, right? And of course, you use AI in almost everything. So,
Ravi, apologies. Can you
yeah,
increase your voice level a little bit louder, if it would help?
volume not clear.
Yeah, it's a little on the lower side. Maybe you can speak a little louder.
Okay, that I'll do.
Yeah.
Because every other volume control on my laptop is at max. So
Okay.
every
Sorry.
volume control I can manage is me now. So I'll go lower. Okay. So one of the things, of course, if this talk had been taking place physically, a lot of you would have been using Google Maps to find your way to the Tamil Virtual Academy, right? And on almost everyday basis, we used to use Amazon, Flipkart, Zomato, Swiggy, at least until about 2 months back. And hopefully, we start using them very quickly again. All of these, right? So many of this is actually possible through some of the fundamental development in AI technology. And of course, again, AI is something that we speak to. I jokingly say that many of the new generation kids talk to AIs more often than they talk to human beings. Whenever they talk to their phone, or Alexa, or Google Home, they are essentially talking to an AI. And just not these kinds of everyday happenings, but AI is also making a big change in healthcare. And so there's a lot of new age solutions that are coming for example, for breast cancer screening that make use of a lot of AI techniques, or to examine X-rays and CT scans. In fact, currently the champion in terms of how accurate you are able to analyze a CT scan is an AI agent, and that competed against other radiologists and doctors, right? And of course, there was some news few months back about how Google has solved the detection for many different eye problems based on the latest AI technology, and in collaboration with some of the Indian hospitals as well. Right? And soon we'll come to a point where AI is going to decide, right, what you see, and who who gets loans, who gets treatment, and so on and so forth. In fact, even things as mundane as what kind of advertisements you see when you go to Google are now decided by AI. So AI is everywhere. In some sense, it impacts many facets of our life. So it's good that we know what is AI. Right? We shouldn't think that there is some kind of a magic wand, right? And that's being waved, and then it just miraculously solving problems. We need to have some understanding of what is this technology. And so let's see what. Of course, there is one huge misconception for AI, right? So whenever I talk about AI, people immediately think of Arnold Schwarzenegger or something equivalent, and but that's not really true, right? But then there are people like Elon Musk who feeds this kind of fear. That Elon Musk says AI could doom human civilization. Mark Zuckerberg disagrees. Who is right? I mean, given all the troubles that Mark Zuckerberg is getting into, uh, so yeah, who is to trust him or Elon Musk? So let's go and listen to more knowledgeable people. So Toby Walsh was the president of the International Association of AI until recently, and so he has written a very nice article on why this is all unfounded fear. Right? But you don't just have to take my word or Toby's word for it. There was a survey of 50 Nobel laureates, right? And they ranked climate change, population rise, nuclear war, disease, well, in times of COVID, that looks very, very present. Selfishness, ignorance, terrorism, fundamentalism, and even Donald Trump has bigger threats to humanity than AI. Right? So, uh, as you will see as we go along, right? So AI is a piece of software, and AI has a lot of faults to it. It's as much a danger to humanity as any other piece of software. If you write up a piece of software that is bad or crappy, right? I mean, if you write a piece of software that is controlling the nuclear trigger in the country and they have a bug in it, it might as well wipe out the world. So as with any other technology, you have to be careful in how you handle AI. It's just not that AI in and of itself. Of course, the other misconception is that AI is a job killer, right? And so that is Flippy the robot that's flipping hamburgers. And so just like in India, we say that if you are not fit for a good education, you'll end up herding cows. So in the US, they say, yeah, if you're not doing well, you're just going to end up flipping hamburgers. But that too apparently is no longer an option. It's taken away by because we can always tell ourselves, yeah, the flipping hamburgers is one thing, but can the robot really make dosa with the batter and make it perfectly in circles, so on and so forth? But really, right? So is our robots threatening our jobs? Are we going to take them away? Right? Is it really a job killer? Right. So here are some news clippings. Right? This will probably answer it in and of itself. Robots taking over, AI to sink world in unemployment. Welcome to the new AI. White collar jobs are safe. Why artificial intelligence will eliminate millions of jobs. Right? And by 2020, AI will create more jobs than it eliminates just now. And artificial intelligence is creating new and unconventional career paths. So the opinion seems to be split among all these news articles. But the bottom line is, as with any transformational technology, AI is going to make certain kinds of jobs. Certainly not cooking hamburgers. It's too expensive to cook hamburgers using AI. But there are a whole bunch of other things, right? So many repetitive tasks, many repetitive jobs, and there are quite a few jobs that are going to be eliminated with the advance of AI. But then, how many phone kiosks, STD booths do you see nowadays? Okay, so as and when technology advances, right, there are going to be jobs that are eliminated and jobs that are going to be created, and there will be small amounts of pain when people retrain to go to new career paths. And I'm not going to say that the picture is all rosy, but AI is not going to take away all the jobs. And as you can see, as you will see through the rest of my talk, AI is nowhere in a state where it can take away all the jobs. So AI has a long way to go before it achieves any that in a broad sense. So having gotten the two caveats out of the way, let's start talking about AI. AI is not new. And a good fraction of the people in the audience might remember this pretty famous matchup between Gary Kasparov and Deep. This happened back in 1997, and I remember it fondly because there was a time when Gary Kasparov lost to Deep Blue, but Vishwanathan Anand beat Deep Blue. And that seemed the only way that Vishwanathan Anand was going to beat Gary Kasparov back then, vicariously. Whenever they used to play each other, he kept losing. But then they could always say, Gary Kasparov lost to the computer. Sorry, Kasparov lost to the computer while Anand managed to beat the computer. Right? But then Deep Blue was an AI engine. This is back in '97. I'm pretty sure that a few people in the audience at least remember the fuzzy washing machines that we saw in the 80s and 90s, right? And how much of a buzz there was about these kind of appliances if there are any AI enabled and so on. So AI is not new. It's been around for a while. So here is a clipping from an old newspaper. Right? So the Navy revealed the embryo of an electronic computer today that it expects to be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So when do you think this article came? Maybe in the 90s, maybe in the 80s. The article is from 1958. Okay, so the hype around AI is not something that is recent, and it has been around for a long time. So in some sense, if you think of beginnings of AI going back to Alan Turing, who in 1950 asked the question, can machines think? And then he came up with it is a very seminal paper, and one of the things that he proposed in the paper was a test, which is now famously called the Turing test for intelligence, which essentially asks the question that if I put a computer in one room and a human in the other, would the second human be able to distinguish between the two just by interacting with it by asking questions? So the idea was that the computer should be able to do as well as the human in answering this question, so that the tester is not able to tell the two apart. So we call it the Turing test now. Any guesses what Turing called it? Right? So that became the name of the movie they made on Turing's life. So Turing called it the imitation game. So how well can the machine imitate it? So
Ravi, sorry.
too loud?
Yeah, is there any way you can get the microphone closer to your mouth and
Oh, wow. Okay. How
your
long has it been low?
people have been complaining that it is a bit low, while they think my voice is quite okay. I can receive your voice.
Is this better now?
Uh, till I mean, I can receive you very clearly. I don't have a problem. But when it is actually going out on the stream, uh, so anyway, just think that you are in a classroom.
I'll
Yeah.
turn off my video. I'll turn off my video so that I can move closer to the camera because otherwise my face will look too big. So let me
No,
turn off
don't. You can go closer because it's only a small window in video. That should be fine. Just try going a little closer to your microphone and then speak. It should be okay.
Okay, is this better? Can people?
Yeah, it's fine. This is fine. Go on.
Okay, fine. So Alan, so we came back. We were talking about the imitation game that Alan Turing came up with. So and then this started a whole movement in the field, and that kind of culminated in 1956 in what was called the Dartmouth Dartmouth project or Dartmouth AI conference. And so there was a conference held in 1956 where about 10 people got together for a period of 2 weeks, and they decided to have a discussion and start a new research discipline. And the whole premise was that they were going to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. Okay? So I'm going to underline the important part. So the machine can be made to simulate it, right? You're not talking about making machines intelligent. They were more interested in understanding what is intelligence so that they can make the computer program behave in a similar fashion. So it was never about creating the Frankenstein monster, but more about understanding intelligence and systematizing it. And so the term artificial intelligence was coined, and then it became the name of the field. And so the pioneers who were part of this conference were John McCarthy, Marvin Minsky, Rob Sharon, uh, Ray Salmanoff, Alan Newell, Herb Simon, Arthur Samuel, Oliver Selfridge, Nathaniel Rochester, and French Floor. And each one of them has made really, really seminal contributions to AI. And 4 of them went on to be honored with the Turing Award, which is kind of the equivalent of the Nobel Prize for Computer Science, for their contributions to AI. Right? So McCarthy was the person who came up with Lisp, the programming language. If you have seen some fragments of text that is above my picture in the announcement for the talk, that is Lisp. And then Marvin Minsky has kind of laid the foundations for a lot of the modern machine learning ideas, and Simon and Newell basically laid the foundation for a lot of logic and reasoning that AI systems use. Right? In fact, Herb Simon went on to win a Nobel Prize in economics as well. And there were 2 people who contributed significantly to AI who are not part of this conference. Those are Alan Turing, who got this whole idea of machines modeling intelligence, and von Neumann, who basically built the foundations of rational behavior in game theory. And these are, we could have a seminar or a talk about each one of these people's contribution to AI, and I'm not going to get to that today. But just know that these 12 people, some major, early major influences of how AI evolved. And some of you might actually, know Claude Shannon from completely different context, and same thing with von Neumann. But both of them actually made significant contributions to AI. And so the development of AI has not been very smooth. It's always gone through several hype cycles. Here I'm just showing you the first hype cycle of AI. In the 1950s, we had the Turing test, and 55, 56 is when they started this whole idea of calling this field AI. Then 61 was the industrial robot. 64 was ELIZA, that could act. That's the very first conversation agent that could hold meaningful conversation with humans. Then 66 was Shaky, which was a general purpose robot as opposed to the industrial robot that was built earlier. But then a lot of the promise that the AI systems were bringing forth kind of did not really deliver. And so by the time you entered the 70s, you got into what was called the AI winter. So that people were not really enthusiastic about AI, and a lot of funding and other things were not there. And then again, in the 80s was the second AI hype cycle started, right? And the mid 80s to mid 90s, again, a huge AI hype. And again, the AI promised too much, or rather, humans promised too much from AI. And we went into the second AI winter. And now we are back into the third AI summer, and hopefully we can match expectations to capability with AI now, and not overhype AI, and we'll continue in this play for a while. And so one of the main reasons AI failed in the previous two cases that we went into AI winters, there was really no large-scale adoption of AI in real-life success stories, and which is not true now. So a lot of, because you saw all the examples that I was showing you earlier, and many of these we experience in everyday life. So there have been significant real success stories for AI, and so people are actually looking at AI as a little bit more of a mature technology now than it was earlier. In fact, some of these negative fallouts have had lasting impacts. So, for example, here is a quote from The Economist in 2007. AI is associated with systems that have all too often failed to live up to their promise. And there's another one. Some believe the word robotics actually carries a stigma that hurts a company's chance at funding. Can you believe that now? Now everybody seems to be falling over themselves. And 80-year-olds want to know about AI, but as little as about 10, 12 years back, AI was not a great term to be associated with. Right? So here is one-line summary of what we have been talking about so far. So replicating human behavior is being now taken to be the hallmark of intelligence. And artificial intelligence is to build machines that can somehow replicate human behavior. So what is intelligence? So I just went through Google and picked up a few definitions. You can talk about it as capacity for learning, reasoning, understanding, and similar forms of mental activity. Capacity to acquire and apply knowledge. The faculty of thought and reason. Superior powers of the mind. Oh my God, I can't understand most of what this means. But just checking the voice fine now. Or?
Still, there are complaints for increasing the audio level, really.
So anything you can do at your end to increase audio level?
No, I think you were starting off. You are loud, and then you were slowly, as you continue, the voice level falls off. I think it's about where your mic is. If it's connected to your earphones, then it will pick up much better. If it's closer to the body, but is it on your? Is it a separate?
I tried both. I tried both, and you said the mic on the laptop is better.
No, mic connected to your headphone is better if you can use that.
I tried both. I tried connecting to the mic on my headphone, and I thought you said the previous setting was.
No, I think you just have to assume that you are in a large class of a couple of hundred people and you'll have to shout out nothing else. Sorry, if you could do that, it'll be great.
Okay, is this better?
I am receiving it fine, but after encoding,
Get feedback from the people.
no, for me the previous one, the one just before whatever you did was better.
So that's the thing, right? So the mic on my headphone doesn't seem to pick up well.
Yes.
So I'll just keep shouting. So I'll just catch myself and keep shouting all the time.
Thank you. Thank you.
Sorry about that. And if I drop off, please.
Sure. I will.
So that I can keep the volume up.
Maybe one thing that you could probably try is switch the video off and see how it works. Your video temporarily.
Okay. I switched off the video.
Okay.
I don't think that's going to make the voice pick up any better.
Yeah.
But let's see.
Also, if there is some kind of a fan or some other background noise in your place, you could see if you could turn that off. It could probably help. Probably to reduce the background noise, if at all. Otherwise, we can continue as it is.
Okay. I have turned off the fan, and if I faint from dehydration.
Sorry about that.
We'll
please. Now they are saying it's good. So let's hope it sticks and we continue. Please.
Sure, fine. So I mean, there's all these definitions, right? So I always feel a little uncomfortable with these definitions because you really don't know what it means. So let's go by examples, right? So do you think playing chess needs intelligence? Well, most of us would agree, right? Most of us would say, yeah, playing chess is something that is intelligent. So, but then we can always get the computer to play chess. Right? 1997, well, this is a more fancy heading. But this is something which Kasparov really made. This is a statement that he made. I could feel human level intelligence across the room. And there is a statement that Gary Kasparov made. And in a few years, even a single victory in a long series of games would be a triumph of human genius. And it's come to that point now. Nobody even talks about computers and humans playing chess because they know that computers can comfortably beat humans, right? And another thing, recently I had a chance to listen to Kasparov talk about this particular event. And so Kasparov says that he was so upset when Deep Blue beat him, not because the computer had beaten him, but this was the first time he had actually lost in gameplay ever to anyone. So, but then he's taken it in his stride, and now he's become a huge advocate of kind of augmented intelligence. He advocates for this new kind of chess where computers and humans jointly play as a team with another team of computer and human. And how about proving theorems? Do we think that proving theorems needs intelligence? Yes. But then back in 90s, so we had an AI agent that came up with a major mathematical proof that would have been called creative if a human had thought of it. We're getting somewhere. How about quizzing? Right? For a lot of us 80s kids, I mean, this is the quintessential quizmaster. I can't think of anyone else picture to put here for quizzing. So what about quizzing? And there was this excitement about 10 years ago when IBM built this engine called Watson that played this game Jeopardy, which is a general quiz competition. It's not just like playing chess or anything, like it's quiz on general knowledge, and it very comfortably beat the humans. Right? And so Ken Jennings was a multi-time champion, but he lost by a huge margin to the Watson engine. Right? So how about recognizing different objects, really complicated things, and so on and so forth? Right. So in fact, if you look at this picture, there are two boys and a girl here, but that requires a lot of prior knowledge and domain knowledge to know that we are talking about two boys and a girl. Right. But then this is something that really kickstarted this modern interest in AI, the third summer of AI. There's this challenge called the ImageNet challenge. Right. There were about 1,000 different categories, images of about 1,000 different categories. You can see these different categories here, the things like dogs and houses and cars and things like that. Right? And the idea was that given an image like this, you should be able to recognize what that image is. I mean, put it into the right category among the 1,000 classes. Right? And of course, humans had about an error rate of 5%. So they made about, if you show 100 images, they get about 95 correct. And even in 2010, AI was doing about 28% error rate. Right? But very quickly, we had significant improvements in technology, and by 2015, we were doing better. AI was doing better than even humans in finding these kinds of object categories. Right? And some of these are very challenging, the kind of optical illusion type of images, but still the AI is able to do much better than humans very quickly. Right? So, in fact, I'll ask you about a bunch of things, but they all boil down to these four, what I would call as intelligent functions, right? So one of them is perception. So the ability to see, hear, etc., right? So ability to perceive the world. And the second is cognition. So understand what you have perceived, right? So understanding text, speech, understanding the visual scene, what is related to what around you, and so on and so forth. And the third major function is reasoning and decision making. So where you use logic and then you plan to achieve certain targets, and then you can also make decisions for others, make recommendations, and so on and so forth. And the fourth hallmark, I would say, is learning and adaptation. So where you learn from examples, right? So you get basically you learn to perceive, you learn to understand, you learn to make decisions, not because somebody has given you the rules, but you are able to kind of derive this from examples. Right? So this is what people typically refer to as AI needing a lot of data. In reality, what they're saying is AI needs a lot of examples. Right? So these are the four main functions, I would say, of an intelligent system. Of course, there are various ways of organizing this, talking about this, but I'm just going to try and keep the discussion simple. Right? So, what is artificial intelligence? Right? So you could think of human-like behavior. When you think of humans as being intelligent creatures, then you automatically start thinking about human-like thought. Do they reason like a human, to behave like a human? Right? So here are different definitions that was proposed at different times. So Bellman in 78 talked about automation of activities that we associate with human thinking, activities such as decision making, problem solving, learning, so on and so forth. Right? So this is talking about human-like thinking. And then we can look at Richard Knight's definition on AI, the study of how to make computers do things at which, at the moment, people are better. Here they have kind of given up the notion of human-like thought, but they're only worried about human-like behavior. But then there is a whole other school of intelligence which says that it's not necessary to behave like humans, but to behave in a more rational way. Right? This is a kind of what people in game theory talk about. So there is people who talk about rational thought, the study of mental faculties through the use of computational models. And people talk about rational behavior. The branch of computer science that's concerned with automation of intelligent behavior. That's a definition of AI, that people who believe that rational behavior is the true mark of intelligence. And so we can summarize these into systems that think like humans, systems that act like humans, systems that think rationally, systems that act rationally. Right? And if you recall, I said that in the olden days, in the beginning of AI, people were more interested in replicating human behavior as a hallmark of intelligence. So that would essentially mean that the old school people were more interested in systems that act like humans, not necessarily about the other parts. But then a lot of development in AI has been towards has been directed to all the four definitions as well, not just on systems that act like humans. Just a caveat here: whatever I'm presenting to you is a very highly simplified view of AI. Right? It is like saying integration is nothing but just a summation of a lot of numbers. Right? That's a very simple view of AI, some simple view of integration, but it's not essentially wrong, right? But we know that it doesn't stop there. Integration can get a lot more complicated, and then these are things that have given a lot of us nightmares in school, right? So, in some sense, what I'm presenting to you is a correct but highly simplified view of AI, and there's a lot more to this. Just to give a caveat, you're just thinking, oh my God, this is nothing to AI. So one thing that so I'm just stopping here to make sure that I'm still audible.
Yeah, I think it's much better now. Much better. At least no complaints so far. So please go on.
Okay. So it looks like I really had to sweat it out for this talk, and that was really what was needed.
Maybe you can switch the fan on. Sorry.
No, I'm not going to. I'm not going to. I think that's what caused the difference.
Okay.
Sure. And so one thing that you should remember is that whatever we have been talking about, AI is not a single technology. Okay? So we have perception. So we already talked about that. So perception. So we have identifying what you see, right? So that subfield of AI is called computer vision, right? So one example task in computer vision could be identifying objects in pictures. So it could be faces, it could be animals, it could be tumors, whole variety of things. I showed you examples of all of this in the talks already, right? So this is one task that you could do in computer vision. There's a whole set of technologies around it, their own journals, their own conferences, where they talk about computer vision, algorithms and applications, etc. And the second part of perception is to understanding the spoken word, so that's speech processing. So you have example tasks could be identifying speakers, words, music, and so on and so forth. And the third part of the perception is to understand written language. Right? So a lot of communication in our world happens through written language. So this falls under what is called natural language processing, as opposed to compiling, like computer language, right? So natural language processing, think of stuff like identifying phrases, syntax, understanding entities, like who are the people who are mentioned in this sentence, so and things like that. And when I'm talking about GOAT in the context of tennis, um, maybe I shouldn't go there, but I'll go with my personal bias. So when I'm talking about GOAT in the context of tennis, it's probably Federer, right? I'm not talking about animal GOAT. So those are the kinds of recognition that we have to do. And so AI has had great success in all the three so far. And in some sense, this has really fueled the third summer round. So that's this is all the fielded applications that we are talking about in AI built on top of one or more of these three technologies. Right? And then moving to cognition. Cognition is understanding of what you see. So the first thing, what you see, hear, read, so on and so forth. The first part of it is understanding what you see. So sometimes goes under the name of scene understanding. So will you be able to describe a picture to a person, or describe a face? How does the face look like? Right? As opposed to saying, okay, there are all these pixels on the face, would I be able to describe this? And the second thing here is in speech understanding. Can I recognize pauses? Can I look at mannerisms, etc.? Not just understanding there are words that are being spoken. Can I look at unspoken cues? Sorry. And the third part is, of course, understanding written text, which is what we call natural language understanding. Can we recognize, idioms, sarcasm? Can we conduct a free-ranging conversation as opposed to a closely scripted conversation with a human? Right? And it at doing everything. So that's something you should keep in mind when you evaluate AI systems. But here comes the big part. So what about reasoning? So far I talked about perception, I talked about cognition. What about let's say, how do we play chess? How to play chess? Right? So in fact, you start off with the initial board position, and you systematically enumerate all the moves that you can do, look at all the outcomes, right? And so you basically would like to take favorable outcomes. But then when you start searching like this, it quickly can become very large, right? I mean, this is a nice, understandable picture, but when you look at something like this, it becomes very confusing. So board positions, the number of moves you could make, and the number of combinations that you could play becomes very large, complicated very soon. Right? So basically, what you need is some clever way of searching through these outcomes. And so for here, I'm showing you that there are a whole bunch of possible positions that you could explore, right? All the red circles. But then I choose the ones that I have indicated there to explore based on some criteria. So what are these criterions essentially, are things which different AI algorithms will give you different suggestions for, and that's how you proceed to learn to play chess, or how to play chess. Right? So this is exactly how Deep Blue did it, right? So nothing very cunning about it. Deep Blue could actually look at many more possible outcomes than humans could, right? And it basically searched through all these outcomes at a rapid speed, right? And was able to play better than humans, right? But is this really how humans play? Perhaps not, right? So here is a graphic to tell you that there's something else that's going on. So look at back in '97 when Deep Blue beat Kasparov, the computer consumed about 15,000 watts of power. And then when the IBM Watson beat Ken Jennings, this is a zoomed out picture from what you saw earlier, it consumed something like 200,000 watts, like 2 lakh watts. Right, and then 2016 there was even bigger news about Google's AlphaGo engine playing a game of Go, right? Very well. But this system used something like 300,000 watts. Right? But all of these systems are competing against the human brain, which is used about 20 watts. So that's a huge energy differential. So we still are behaving. AI is still behaving like how humans behave, but certainly not processing things the same way that humans process. So let's talk about a little bit of another reasoning problem. How about proving theorems? So basically, the skeleton is very similar. You start with known facts. You have a whole bunch of rules of inference. And so if this all looks very complicated, let's make it simple. So when you start with known facts, it means you start with some kind of initial board position in chess. And the rules of inference are essentially the rules of the game. And when I repeatedly apply the rules of inference, and it's like I'm playing the game and trying to come to an end point, right? Now, this whole thing is not trivial when it comes to theorem proving because the rules of inference are much more complicated than rules of games. And to even understand that I have come to a end point is not trivial. But then we can see that the basic approach of all these AI algorithms is to think through systematically how humans arrive at these decisions and try to automate this. Right? Maybe not quite the same way how humans do it, but in some kind of a meaningful fashion. So now we kind of when they start talking about things like this, it takes the mystique out of AI, but that's the whole point. Right? And so, in fact, reasoning and decision making is the one area where a lot of attention has been paid in AI. Right? So we have theories of logic, we have things like decision theory. I mentioned game theory earlier. We have this whole literature on how people come up with plans or how AI can come up with plans, which again is very similar to all the searching that we talked about. Right? You start off with the initial position that you are in. Okay, I'm home, and I know I want to really get to some shop, and how do I plan my route? And then I think of what are all the different things I could potentially do. Okay, I can probably take a bus, I can walk, or I can call for an auto, and then this example sounds really dated, doesn't it? Uh, okay, this example I worked 2 months back, but not today. But the point is, you see, so I look at all the possible alternatives that I could consider, and then I continue moving till I reach to the goal that I wanted to. So this is again very similar in spirit to what we talked about earlier. So in popular imagination, right? So I asked you what are all the things that need intelligence. Typically, people come up with this planning, the kind of reasoning, decision making, and learning as the true hallmarks of intelligence, not necessarily the perception and cognition. But you really can't apply any of these without the perception, the cognition pieces. And it turns out that it is non-trivial to automate those, and it really requires AI technologies to do that. So this brings us to the last part. So what about adaptation and learning? Right? So there's this whole area called machine learning, which has now become very popular. In fact, nowadays people use AI and machine learning almost interchangeably, and maybe not. It's certainly not all of AI, but it's certainly the most successful part of AI that you see nowadays. In fact, almost all the successful applications that I showed you when I said AI is everywhere, a good fraction of that, almost all of it, yes, are due to machine learning. Right? All the later success stories I showed you, like chess playing and theorem proving and so on and so forth, used more other kinds of AI techniques, including the Watson Jeopardy player. But certainly the initial examples I showed you, Google search and maps and so on and so forth, use machine learning maps. So what is the idea behind machine learning? Right? So the idea behind machine learning is, instead of me giving you the rules or me telling you how to organize your search and so on and so forth, what I'm going to give you are a set of examples, right? Like this. So all of these, this is from the ImageNet challenge, if you remember. So all of these are airplanes. All of these are automobiles. All of these are birds. So on and so forth. I'll give you a lot of examples like this. So from analyzing these examples, or somehow you learn a way, a mechanism to classify a new image into one of these categories. Right? Here I'm showing you only 10 categories, but image might have 1,000 categories. So the idea is that if I give you a new image, you somehow classify it in one of these categories. I don't give you any rules. And so what really caused all this recent excitement in AI is we came up with a machine learning technique that could learn like this, right? So it could learn by starting off with simple, color patches and lines, and then it could look at all kinds of textures and edges and so on and so forth, and then it started looking at more and more complex features, right? And then finally it started looking at parts. So this essentially this part is highlighting bird legs, and this part is highlighting faces of a dog, right? And here now finally you basically say, okay, if if it looks anything like this, then it is going to be a dog. If it looks anything like this, then it will be a dog. That's essentially what you've done. So you start off by, when I'll give you images like this, right? So and then slowly the machine learning algorithm learns these kinds of representations. And nobody tells it these are the representations it has to learn. All it is told is, okay, this picture belongs to a cat. This picture is a dog. And this caused a lot of excitement, right? So this technique that allows this kind of layered learning of features is called deep learning. Pretty sure some of you have heard of deep learning. And I just showed you an example with 5 layers, but then people have gone crazy. There are algorithms that use 8 layers, then 19 layers, 22 layers, and even things that use 152 layers, and so on and so forth. Right? So this is essentially called deep learning, where indicates the different layers, right? So the layers essentially corresponds to more and more complex features that you are learning from the images. So the images is one thing, but you can learn features from other kinds of inputs as well. Right? So what really is driving, fueling this third AI summer is the success of deep learning to achieve superhuman performance. And the same thing happened with speech recognition. Deep learning systems have been able to be humans. In fact, at some point, some fancy experiments, personal assistants, right? And the latest version of these can actually, do lip smacks like that, and do accents and so on and so forth. And they can even give meaningful pauses when they talk. And so we certainly come a long way, and then in fact, to the extent that it can even produce art. I mean, this always gets me, right? Given a doodle, the AI actually produces a painting that is the style of Monet, because it was trained with a lot of examples of Monet's paintings. It's really amazing. And here's another success story. This is the game called AlphaGo. So if you remember, I was saying that in chess you enumerate all possible things you could do, and so that is called the branching factor. Right? So chess has an average branching factor of 35, or across the boards you can have a branching factor of about 35. Well, Go has a branching factor of about 250. So it's very hard to play Go using the standard AI techniques, but then Google DeepMind built this technology that beat the world champion. And in fact, it did something amazing. It trained, the Alpha Zero, which is a follow-up engine, trained just by playing against itself. Right? It did not need any human to tell it what is right, what is wrong. It just played against itself. It knew the rules of the games. It played against another copy of itself, and then kept playing until it became very good. Right? And so you can even see Vishwanathan Anand comparing it to Stockfish, one of the top chess playing program. And so basically Alpha Zero beat Stockfish in a very lopsided scoreline. Right? So of course, I needed to have this topical slide, AI and COVID-19. There's a lot of work that is happening. So people keep talking about how can AI help with COVID, and a lot of new stories that are popping up. And of course, many technologies of AI can help. So we talked about a few already. So computer vision, right? So computer vision can help you understand, CT scans and X-rays better, and potentially do early detection of pulmonary problems. And this could happen only if, of course, we have a lot of data, right? A lot of examples already, so that you can train these systems. And people have started actually pushing out applications that can do this. And of course, language processing, can be used for finding connections between the hundreds of papers that are written on COVID, and trying to see connections that people have missed because they're not aware of all the literature. And the general machine learning data analysis techniques allows us to predict mobility patterns, can help in contact tracing, and also help in predicting severity of infections from various other biochemical factors, not necessarily the COVID test that people are doing right now. And of course, one of the things I forgot to put on the slide, it's also AI is also helping in the search of new drug candidates for treating of COVID-19. So, I mean, all of these things which I have put in here are not hypothetical potential use cases. These are all places where AI is actually being used in the current scenario. So the current thinking as far as machine learning and by extension AI is that all you need to succeed in AI is have large volumes of examples, right? Large volumes of examples, which otherwise people call as data, right? Preferably tagged data. So humans have looked at it and said, okay, this is a right, like we had earlier. This is a cat, this is a dog, and so on and so forth. And from some problems like Go, you just need a simulation model. You don't need anything more than that. Right? And hence, a lot of investment nowadays is going uh, uh, into generating the data. Building successful product means you just have the data. Right? So people have coined phrases like data is the new oil, it's the new water, and so on and so forth. Right? But just hold on. Right? This is not how we learn, is it? So we have teachers, we have textbooks, and we learn from peers, we learn from examples, of course, but that's only a small fraction of the learning that we do. Right? We don't always learn from examples. And we have a whole bunch of other knowledge sources that we imbibe. Right? So yes, so this is not how we learn, and this actually causes some problems for. So it's all fine when the going is good. So you can see what is happening here. It's trying to describe, the AI is trying to describe the scene that you see. A person riding a motorcycle on a dirt road. That looks good. A group of young people playing a game of frisbee. That looks good. But let's look at some examples. A skateboarder does a trick on a ramp. But that guy is obviously riding a bicycle. A little girl in a pink hat is blowing bubbles. Pink, okay. Hat, I'm not sure. Blowing bubbles, certainly not. Right? So now if I ask the question, hey, why did you do that? Right? So why did you make a mistake? AI's technology can struggle. Right? So people realize this, so there have been some effort at addressing this. So let's take an example, look here. So here's the original image, right? And the AI, here's the original image. And the AI has actually labeled this as having a cat and a dog. And then you ask is, okay, where is the dog? And it tells you where is the dog. It looks fine, right? The more red it is, that's where the AI thinks about it. Then you ask, hey, why do you say there is a cat? And it gives you this as the reason why it says it's a cat. It's basically the hind leg of the cat. If I ask you why you think there is a cat, you'll probably tell me something closer to the face. Right? So this is again a little weird, but it's okay. We can live with this. But it becomes more critical in healthcare. So deep neural networks have found great success, and they can find all kinds of lesions and so on. So I'm just picking an example that, and this is just a hypothetical scenario, right? So this, whatever I'm going to describe in the next few slides, never happened. So somebody comes and asks, why did you say this person has diabetic retinopathy? Right? And the AI comes back, blocks out a region and says that, okay, this region looks exactly like the ones I saw only in people with diabetic retinopathy. The doctor says, oh, that's just normal age-related degeneration. It's nothing to do with diabetic retinopathy. The AI says that, hey, but then you never showed this to me earlier. So I just thought this was diabetic retinopathy. It's your fault. But the point is, I mean, the AI is not advanced enough to say any of these things. Right? The AI will only tell you that this region looks like the ones I saw only in people who have taken, right? But so you really now have to start thinking, right? If this is what the AI can do, then if I put the AI into use, right, then maybe it is my fault. Right? So you really have to think whether it is your fault that the AI is making all these mistakes. But remember that explanations are very, very important in the context of applying AI. The medical domain is one, financial domain is another, and we are still quite a bit of ways off before we can get explanations. Right? But then, okay, let us say I'm not able to do explanations, but how robust are is AI predictions in general? Right? So here is an image, and I ask you what is the label, and yeah, the AI tells me it's a school bus. And here is another image with some random noise, some noise added to it. But this is what it looks after the noise is added, right? So can you tell me what this is? Well, it's obviously an ostrich. Right? Well, at least that's what the AI thinks it is, right? Because it is it's learned some kind of weird features to describe that as a school bus because it got it correct the first time. But even the small amounts of noise, it makes it into an ostrich. And this is just not one-off. People have shown this repeatedly. That here's an example where the panda becomes a gibbon and the dog becomes an ostrich, and so on and so forth. And it's not too hard. It's not too hard to fool an AI into making these kinds of erroneous conclusions. And so this is not always due to attacks, right? Not always because I'm adding these kinds of noise. It could be that there's a really rare sample with the presentation of a disease that's not very common, so I might miss it and say the person is normal. Or the data that I used, the examples that I used to give to the AI could have an unidentified sample bias. So here is an example of from Google's engine a couple of years back, where it got most of the things right, but the one in the red, right? So it made a big mistake, and that's as you can see, that it's a very, very sensitive mistake to have made, and that is because primarily the training data had mostly white and Chinese images and not enough African American images. So it basically made this error. Right? Errors are not always due to attacks. So if the AI is so fragile, right? So why is it that we say that it has got a huge success rate? Right? If you think of all the cases where I'm showing you that it has success, right? It's like analyzing a high fidelity radiology image, or looking at images on Facebook where I'm marking the faces and so on and so forth. These are all applications where I really want the AI to do well, right? These are not applications where I'm attacking the AI, right? So these are not applications, where there is some kind of intent to defraud and so on and so forth. And in such cases, AI techniques will do really well, right? But in cases where there's a chance of a third party attacking the AI, or where there's even a small mistake can have a huge cost, like in this case, right? Opening you up for a lawsuit and so on and so forth. In such cases, you really have to worry about deploying AI. I don't think it's ready. Here's a fun example. So it's actually touted as a very hard challenge where you get a humanoid robot to balance and then play football and kick things into the goal, right? It looks to be doing amazing stuff. But here's an example that now the goalie just lies down on the ground and just acts like a baby and cries. The guy who's supposed to score the goal gets very confused and doesn't manage to even get near the ball, right? So basic fundamental problem here is that my AI is just learning all kinds of associations from the examples that was given to it. It doesn't really have any knowledge of the structure of the world. It doesn't understand the physics of the world. It doesn't understand what how things will behave, how things will evolve in the world, and so on and so forth. Right? I mean, we'll think twice before saying something is a real thing as an ostrich, but the AI doesn't have any such mechanisms right now. Right? And the doctor could tell you why some artifact in the image is the reason for a diagnosis, not merely because 10 people before you had the same artifact. Right? So the AI doesn't have this kind of information, and that is something that we really have to address. So how can I fix this machine learning approaches to AI? One way of doing it is to integrate it with more classical AI, looking at logic, reasoning, knowledge representation, all the things that we spoke about in the beginning, right? and to go beyond classical AI, right? Talk about process model, talk about what the engineers have done so many years. Can I take ideas from that? Can I take inference from that, and then make AI richer and more robust? So that's the way to go. Its AI is undoubtedly successful, right? In very specific domains, AI has reached. AI actually has enabled a lot of things that wouldn't have been possible without that, without the development of AI technologies. But the current AI-based systems understanding of the world is that of about a 2-year-old. Maybe if you're generous, you can say 3-year-old. It's a long way to a human-like performance. But in the meanwhile, we have to handle AI with care because it's not like any other 2-year-old. It's more like this kid. With a lot of superpowers, it doesn't know how to control. And if you aim it in the wrong direction, it can cause a lot of damage. So summing up, we are closer than ever to functional AI. Again, because we have done this, the AI community has done this in the 60s, done it in the 80s, and we're doing it again. But I think we really are closer to functional AI, and we should be able to get out into the field, get out into the market with more products and so on and so forth. But importantly, it's affecting many aspects of everyday life, and there is no better sign of this than lawyers and lawmakers getting into AI, right? So when you start, you see an MP or a MLA start talking about AI, or a chief minister talking about the AI policy of the state, you know something is happening. For me, the biggest danger from AI is not AI itself, but humans who are going to rush to the market before the technology is ready. So we really need discussions on regulations for AI, not because the AI is dangerous, because the humans are dangerous. And we need to really answer the question, was it really your fault? Whose fault was it for the AI to perform the way it did? Of course, everybody will be ready to take the credit, but we really need to look at this question in greater detail. Right? And so I'll stop here, and here are a few books for people to follow up on. So the Russell and Norvig book on artificial intelligence modern approach, I refer to it as the Bible of AI. And it has everything that you would really want to know about AI in one book. Right? And for a more accessible introduction to AI is this book by Melanie Mitchell, which is recommended highly by Ramanan. Is a guide for thinking humans. And then there is this other book written by Pedro Domingos called The Master Algorithm. And so the subtitle says it all, how the quest for the ultimate learning machine will remake our world. And then there is this other very, very recent book by Stuart Russell called Human Compatible. And this really talks about how AI is close to achieving success, but what would be the impact on the world if AI does achieve success? And how would you, what are the changes, what is the impact it's going to have on human life and society in general? Right? So Stuart is one of those really, really deep thinkers about AI, and he is influential in many, many advances in AI. And so he has written this amazing book on that. And the final recommendation is the Judea Pearl's book, The Book of Why, and which is talks about everything that is really wrong with the way AI handles reasoning now, and how we should ask the question why. What is the cause and what was the effect? Why did something happen? Before we really can undertake successful reasoning. And Pearl was a Turing Award winner, and so this might be of interest to people. He is also the father of Turing. So that's basically it. I'm ready to take questions.
Thank you.
I hope I was audible for the second time.
Yeah, it certainly was. So we don't know exactly what the reason is that the audio wasn't that good.
The fan.
Sorry. You could probably switch the fan on now.
No, that's fine. I'm fine.
So there are, thank you, Ravindran, for an excellent talk. I completely enjoyed it. I have few questions,
Sure.
and there are also perhaps questions from others as well. So let me just ask one. The first simple basic question is, where is it being used in a productive manner today? That is something that is actually something that was not possible earlier. as of now, with today's technology in AI, what is currently being used in a large sense, which is actually useful to the society?
So is Google search useful to the society?
Yeah, sure. Yes.
Yeah, very good. A lot of things that are happening in Google search, right? So earlier, when Google came out, right, so they had this idea called the page rank system, which was essentially using the connectivity information alone, right, of web pages. So basically, which web page points to which web page and so on and so forth, and they were able to give you search results. But nowadays, the whole search ranking system is derived through a machine learning algorithm. Right?
Okay.
So they have a lot of data that they gathered over many years. So they are able to give you more focused results, and in fact, they are able to give you tailor-made results for you. In fact, I have this joke. So when I search for, I told one of my students to look for an algorithm called the party game algorithm. And when I go to Google and search for party game algorithm, it actually shows me party game algorithms as the first hit. When my student went and searched for a party game algorithm, it showed him a lot of games to play in parties.
So the search is based on your past searches.
Past history, and a whole bunch of other inferences that they make based on your location, based on the kind of queries that, of course, Google uses a whole bunch of other things like your email threads and your past search history and other behaviors that is shared with Google. It's a little scary sometimes when you stop and think about it. But yeah, so the Google search is one example where it has been used in really large.
It's a question from Dr. Ramkumar Lakshminarayanan. How we can decide to use ML or deep learning for a problem? This is question.
There is no real difference. I mean, deep learning is just another version of ML, right? So there are times when deep learning would work better, and there are times when machine learning would work better. So let me put it this way. So if you are looking at a problem where the input is pretty complex, like an image or language, and so on and so forth, deep learning is more likely to have success. And when you're looking at a problem which is much more, the input is much more structured and simple, right? Like a table. Like if you're looking at an Excel sheet and then you have some kind of enterprise level prediction problem and so on and so forth. And the chances of deep learning doing that much better than machine learning is very slim. But the amount of effort that you have to spend is very large. In such cases, I would recommend going for more classical ML approaches like some names, random forests or SPMs and things like that. But this is a very generic guideline. So in some cases, even with text and images, you might want to use classical machine learning because you don't have enough data. And sometimes even with tabular data, you might have some success with. But by and large, complex inputs, large number of data points, go with deep learning. More structured, simpler inputs like tables, go with classical.
Ravindran, you showed one of the slides about proving theorems, for example, right? Okay. Now, even before going to proving theorems, for example, when we were using computers primarily for crunching numbers. And then the symbolic manipulation programs came up, like our MATLAB, Mathematica, etc. Right? Now, so in a sense, today we do have the power, though not everybody is aware of that. It's only in the academic circles primarily. AI combined with symbolic manipulation. What are the things possible even today? Whether we are proving theorems or not, can we solve more difficult problems? I don't know. I mean, I would like you to say a few words there.
Okay. So AI with symbolic manipulation. So there are a bunch of directions in which this has moved. But unfortunately, it is kind of stuck in wherever it was like 15 years ago. Right? So you can do a whole bunch of more common sense reasoning stuff, which is the simplest way I can put it is that so you know how, I mean, this is mainly for people who know a little bit of data handling. Suppose you know how the SQL tables are organized. Right?
Right.
So
Right.
you have like primary keys, foreign keys, and then you have attributes associated with each of these keys, and so on and so forth. Now, classically, AI would have flattened this out. Traditionally, machine learning would just make it into a long vector, right, and then learn on that. Right? But now with the symbolic manipulations, you can actually treat the keys as symbols and then look at relationship between these keys and then do reasoning on that. So you are able to do a very complicated reasoning in terms of things like drug reactions and so on and so forth, right? And also looking at trying to understand medical records of human. This is actually a real application. So people have come up with looking at medical records and constructing a symbolic reasoning system on top of it and making diagnosis which are not immediately obvious from those records. Right? So these kinds of more what I would say learning with symbols and relations are possible. Uh, but the last 15 years or so, the entire community has gone crazy with deep learning.
Mhm.
So the advances are kind of stuck in that time.
Okay.
And yeah, so people don't really spend too much time on proving, I mean, things like theorem proving because it's really hard in terms of encoding the whole domain of knowledge you want to do in proving non-trivial theorems. But people do look at things like reasoning with medical records and looking at a whole collection of data tables and reasoning on those and so on and so forth. So some significant successes in that space have been a lot a cardiac study that happened in the US where the people have used this kind of symbolic reasoning and have established certain things which the doctors believe were correct, but then they have shown that actually the data supports it without actually feeding in the beliefs. Things like stuff like if you smoke when you are a teenager, doesn't matter what you do after that. If you smoke regularly as a teenager, doesn't matter what you do after that, your chance of a heart disease goes up.
Okay.
Right? So I mean, so things like concepts like teenager, those had to be bought in. It couldn't. It's not just a question of just looking at numbers. There had to be this kind of a symbolic layer that needed to be imposed on the numbers, and then looked at the reasoning.
We have a question from Gopalakrishnan Rangaprasad. Since the data is the oil for the AI, is there any sanitization process within AI just to ensure the correctness or rather fairness?
Okay. I did say that yeah, complete reliance on data is not the way to go. But sorry, I'm just looking for the data slide. Yeah. So, and I did point out a whole bunch of caveats after that. But of course, that's a huge effort that happens in generating the data. So when I talk about a lot of investment in building successful products goes into generating the data, I mean in both in generation as well as curation, as well as noise removal and everything, right? So there's a whole bunch of things that happens with the data, and despite that, right, biases do sneak in. So people talk about two kinds of biases. One, they talk about what are called algorithmic bias, and the other one they talk about it's called the data bias. And I think the bigger problem is the data bias now, because quite often we don't even recognize the bias data, right? I don't know. Can I ramble for another 20
Yeah, go
seconds
on,
in
go on, go on.
answer to this?
Go
Okay.
on, go on.
So no, this is from an experience that we have, right? So we were working with a company where we were looking at gear heads and then trying to detect whether there was a fault or not. And we trained a machine learning system on. In fact, we did a lot of work. So we had to standardize it. So we had to create a stand with the 3 cameras which are synchronized and taking pictures and everything, so that the data was very clean. Right? So every gear was photographed in the same angle with the same lighting, all of that. And then we trained it on a system, and then we trained it on some number of images. And then when we tested it, right? We basically had something like only 3 errors out of 700 images, right? So you will be happy to ship it, right? And then we actually wanted to look at what the 3 errors were, and one of those 3 were actually a mislabeling by the human. It was a good gear, but the human had mislabeled it as bad, and our system had said good, and so that was great. The one was a genuine error, but the third one was a problem. The third one, the gear had actually broken into 2. The gear, like, it's just hanging together. Right? The piece was just hanging together, and our system had said that the gear is good.
Okay.
So now, the reason this happened was we had never seen a gear like this during our data generation training process. We were lucky that we got a gear like this in the testing process, because otherwise we would have missed this altogether. And the 2 pieces of the broken gear had no faults on it. Right? So our system said this is all fine. Then we went and spoke to the people who actually do the manual inspection, and that fellow said, "Sir, I have been doing this for 10 years. I have never seen a gear like this." Okay. But now, if I tried to ship this product out and I tell them these are the 3 errors, they can say, "What a stupid system have you built? That is obviously an error. You know, even a 2-year-old can tell you that thing is broken. How can your system say that it is not broken?" Even though we got a lot more subtle errors, we are doing better than the human. And this is a data bias that entered into it, which no one had a clue could enter. Right? So we have to be really careful, right? So we should have some kind of very fundamental mechanisms built in. Things like, okay, there should be structural soundness. Maybe it is not going to show up in your training data, but even in the future, if something like this happens. That's why I said lucky we got it in the test data, because after we ship it, and it happens during deployment, right, and it actually passes a product like this as correct, right, and you can imagine what kind of liabilities will be ending up. So while cleaning data is very important, data bias is always there, and you still have to control for things very, very carefully. So this is one part of it. This is just talking about the actual viability of the product itself. There's of course this whole other thing which people talk about as far as data bias is concerned, where they talk like that the African American being labeled the gorilla, or there is this system that was being used by the US courts for deciding who should get bailed or not, and it turned out that that system was unfairly rejecting bails for African Americans while giving bails for even questionable people of other ethnicities. Okay. And it turned out that was because of a significant data bias in the training of the system, and now they have discontinued using the system in the US. So these kind of ethical issues that arise due to bias is always there, and so there are technologies now people are using to test systems for these kinds of bias, but still a long way to go. Okay. Very early days, I think. The more you start using it for these kinds of critical things like deciding on bail on or who gets treatment and so on and so forth, it becomes
there's a question from Shantala. Is IIT Madras and Professor Ravindran doing any collaborative work with corporate companies around in India in this AI field? Have there been any contributions that we may know
of? Yeah, we collaborate extensively with companies, and yeah, I mean, if you can look at our webpage for figuring out what are the various companies. Look, I think at this point our center has MOUs with at least 25 companies, and we work very closely with them. And there are a bunch of things that we have done, and so at least I'm not sure I can talk about everything we have done with the corporates. Other than that, I can talk about
anything that you can say without mentioning the name of the company or the details of the project. Roughly, I mean, sure. Something that sure. That's been largely, a unique contribution that you can proudly mention.
Okay. So we collaborated extensively on building an analytics project. I mean, like a product for a company. This was essentially, I might as well mention. So we worked with Ericsson very closely on building one of their earlier analytics products. So the product is no longer supported, but it actually did come to fruition. A lot of work was done internally, but our interns contributed significantly in the building of the product. And there are a lot of algorithms that we came up with in terms of predicting who is likely to churn out of a network, and so on and so forth. So that's one part. And then we collaborated with another company to build an internal tool for analyzing the feedback that they are getting about their products on the internet.
Okay.
Right? So the company was a little old school company, so they used to send out questionnaires to people and waiting for them to fill in the responses and stuff like that. So instead of that, we just went out to the social media, and not social media, online, just looking at people's blogs and stuff like that, and then basically fill out the questionnaire for them. Right? It is not an easy job. The questionnaire had something 135 questions, which had all kinds of details, and then we had to extract that and fill in that. So that is one thing we did. Very recently, you probably get an announcement about this very soon. We have been working with Google on their AI for social good initiative, and so we collaborated with an NGO called Arman,
Okay.
which looks at improving pregnant women care in India. And so we very recently did pilot testing of the project, and it's very successful. And so essentially now we are moving into field deployment of the product, which should happen before this month end. There should be an announcement saying that this thing that was jointly developed between Google and IIT Madras is going to go into the field. So this is essentially to make sure that pregnant women don't drop off a wellness program. Right? So we basically predict beforehand how likely is it that they're going to stop, getting inputs from us, and then they drop off the program so that the NGO can do meaningful interventions. In fact, the next stage of the program would also be to start designing interventions for specific people that make sure that they stay on the program and so on and so forth. So that's something that we are doing that's really exciting for us.
Okay. Ramanan has a question. What is explainable AI and interpretable AI?
Well, I talked a little bit about explanations, right? So I was asking you about what is the dog, what is the cat, and so on and so forth. Where is the cat? And this explanation becomes very, very important, like when you're using it for critical applications like healthcare and in financial domains and so on and so forth, right? So this whole field of AI, where they talk about being able to explain what the AI is outputting in some kind of terms that is accessible to the human. In fact, if you remember the picture, right? So I can ask it, okay, it says it's a dog, but I can ask the AI the questions, okay, why do you say it is a dog? And then the AI just circles that part of the image, right? So that is an explanation. In some sense, it's at least understandable for the human saying, okay, this part of the image is probably where the dog is. In fact, our center has an algorithm that is even better than the one I'm showing. I basically picked this to show you that explanations are not perfect. So we have an algorithm that can do better than this. But so algorithms that actually look at giving these kinds of explanations, right? So basically constitute explainable AI. And these are very, very important and very, whenever we are going to move AI into large-scale deployment, these kinds of explanations are needed. And these explanations are not needed just for debugging the AI, but actually at deployment time, when I'm denying the loan to somebody, I can't just tell him that, oh, my neural network had a threshold of this much, and therefore the activity was here. And I mean, I can't do that. Right? I have to tell him that, oh, we are denying this loan to you because of X, Y, Z.
Following reasons.
Whatever reason. Some reasons for which he can actually, wrap his head around. I can't quote linear regression and coefficients and stuff like that. So this is what explainable AI is all about.
Okay.
And there's also a slightly different flavor that people are working on called interpretable AI, where I'm not really, the explainability part is really hard. So instead of that, I'm just going to tell you that I'll give you a very, very simple solution. It's not going to be, I'm not going to give you fancy explanations like this, but the solution will be so simple that you can attach whatever interpretation you want to.
Okay.
And that's why it's called interpretable AI. Right? So instead of looking at all these complex neural networks and things like that, maybe I'll give you some, if then else rules.
Okay.
Right? So maybe you can just look at the rules and you'll understand what is happening. You don't need me to give you explanation. So that is called interpretable AI. And there's a lot of work happening in both spaces, but explainable AI is kind of the next big problem that AI has to solve.
Okay. There was an article in the New York Times and also a podcast where a certain shadowy company had pulled a lot of data that is publicly available data about personalities, etc. And it was being used by the law enforcement authorities in some of the states. And it was even, not just the standard social media, but it had, anytime any image or anything that had been out there on the net, it was basically pulling all of that and building a complete picture. And it was being actually used by the law enforcement authorities, and this particular reporter then starts digging into it, trying to figure out which is the company, and the company itself is sort of hiding behind. So there is this general fear that AI as a tool, combined with the kind of digital footprint that many of us are leaving willingly and without our knowledge, can be used particularly primarily by the law enforcement authorities, but it doesn't have to just stop there. Any company that builds a tool can monetize it in any which way it wants. So there is that huge fear of how it is going to be used. I mean, I don't know whether people have even put out all the dystopian, list of how all it will be, badly used. But basically, there is this fear that article and podcast were actually elaborating. So, I'm sure you would have thought about it. You would, in many of the symposias, you would have discussed it. So, anything that you can add on that?
See, yes, it's possible. The technology is there. There's nothing that can do about it. The technology is out there, right? And the only way to stop this from happening is, unfortunately, legislation, right? Regulations and legislation. So, I mean, people are putting out knives. I mean, who's stopping you? Who's only asking you to use it for cutting vegetables and not other things, right? Everybody, actually, every house you go to, there is a huge selection of weapons you can have.
Sorry, Ravi, think about it this way. There have been knives, guns, and basically we are talking about genetic technology and AI. Now, the first two, there are controls, and there is no large scale. I mean, a gun kills more people than knives, and that is why most countries have, leave out the United States of America. Most countries have sensible laws banning guns. You can't do genetic manipulation just like that, though there are some.
I agree. I agree.
So AI, on the other hand, I can sit quietly. I mean, the tools are available to me, and you don't even know that I am doing that. And I just.
I agree. See, the point is, the same thing holds for guns, right? I mean, you don't know whether I have a gun illegally in my house or not. But the penalty for using it illegally is very high. Right? So the AI technology is out there. So you should have a way by which there is a significant deterrent if I'm using the AI to ruin your life.
Would you even be able to know? For example, I have built this phenomenal AI tool, and I'm basically, I'm this evil bank where I'm supposed to actually be fair to everybody, but I'm actually, without any of even my employees knowing, there is this big brother which will churn and say, this fellow I'm not giving him a loan because prima facie the documents are all fine, but this person's behavior elsewhere, or words in a chat in Twitter with somebody on some day, indicates that he may not pay the loan properly, wantonly, and therefore I'm denying the loan. I'm just taking an extreme.
No, that's fine. Yeah, like this guy got dismissed from a Disney movie.
Yes. Yeah.
Because he had a tweet from 20 years back.
Yeah. Exactly.
So, well, sure. I mean, see, whether the main point I'm making here is the technology is there. There's nothing you can do about it, right? So, I mean, what you can do, whatever you're saying now, is then it behooves us to build technologies that can figure out when AI is being used.
Well,
or when AI is being misused. But the point is, you can't say that the technology cannot happen, because it's happened. It's there.
Okay.
And we have to figure out how to manage it. So it's not so to say that, oh, we need to somehow stop AI from doing this. The horse is bolted.
Okay.
So we have to be,
Yeah.
yeah.
There's
Sorry.
just a couple of more questions.
Sure.
Gopu or Ramanan, if you want to add anything, fine. But just one
Okay,
question
okay.
which I'll quickly read out. In one of the slides, this is by Prem, we see. In one of the slides, the energy consumption in watts was shown, how the calculation is done, and how the work is proceeding in this
Oh my
in that
God.
direction
I,
of
I'm
reducing
not
energy
sure.
consumption.
I'm not sure how they calculated how the humans consume that energy. But the machines, of course, it's doing a typical run, and they know how much power the machine draws per you know, per minute of operation and so on and so forth. And based on that, they made some estimate of the power consumed by the machines. But I'm not exactly sure how they estimated the human power consumption. But I presume these are accepted numbers. So I assume they had a rigorous way of doing it. So how are we proceeding in terms of reducing the power consumption of AI? There are two-pronged approaches that are happening. One is people are trying to improve the architectures itself. Right? So, for example, AlphaGo, when it originally happened, they used 280 GPUs, but they were able to reproduce the same kind of performance with about a tenth of the compute capabilities a few years down the line. Right? So from 2014 to 2018, they managed to bring it down significantly. So from the computer hardware point of view, people are doing a lot of work in terms of making things more compute efficient, and making computers that are very very specific for doing this kind of deep learning computation, so that the energy consumption is less. And from the AI side of things, people are looking at newer and newer algorithms that are aware of the energy that is being consumed, and trying to come up with approximate solutions, right? That trade-off energy versus accuracy. And the nice thing with a lot of AI algorithms is the computation itself is not very internally, the numerical, the number crunching itself is not done at a very high accuracy, so it's okay. So if you can come up with efficient ways of trading off accuracy with energy, then that's a good thing, and that's a direction which the research is proceeding. It's just that we have not come to a point where we can have commodity solutions on this. But there are people like Qualcomm who are pushing AI out onto phones and things like that. So, but then these are much simpler AI than the one that is used to be that used to play AlphaGo or Jeopardy. But still, so there's this whole spectrum of AI use. So for some of the simpler algorithms, we have things that can run on your phone without actually heating up your phone.
Yeah,
In fact, they are running right now.
Ravi, probably like how the over time the computer chips have improved with floating point arithmetic, special chips to image processing chips. Probably there could be a AI specific chip that is added, which will then does not have to share with the rest of the CPU, and it can separately do the necessary computation and then push the results to the main CPU.
That's exactly the direction that people are doing. So there is something called TPUs now from Google, right, which is essentially meant to really execute TensorFlow pipelines, nothing else.
Right.
So TPUs are much more energy efficient than GPUs, and that is essentially what happens. So instead of 280 GPUs, they could run it on something like 8 or 18 TPUs.
Okay.
I forget the exact number. But so that is one direction. Then of course a whole bunch of other things. Not just the CPUs. People are actually looking at memory architectures and reducing latency, memory latency, the power that is required to access memory, and so on and so forth, because they know that it is a deep learning system accessing the memory.
Okay.
So all those kinds of improvements.
Yeah. I think there's one last question we can end it, which is also a very relevant question. This is also from Gopalakrishnan Rangaprasad, who says, if you want to learn AI, who doesn't have much experience in understanding algorithms, many cloud providers providing AI ML as a service, which would be a good place to start, or any suggestions?
AI ML as a service. I don't know if I can make a strong recommendation one way or the other. It depends on a lot on the applications that you are looking at, and so all the major cloud providers have AI ML as a service, right? So Azure has AI ML as a service, and so does AWS, and a few other software as service players are also there. So I don't know. I mean, frankly, I have never used any of these AI as a service things because they're all canned algorithms, and we are typically working on building our own algorithms. And but what I have heard is that no, I'm not comfortable making a recommendation.
Okay. Okay.
That's
Okay.
because I don't have personal experience doing this.
Okay. Wonderful. Thank you, Ravi. Gopu or Ramanan, you want to?
I thought Gopu had a question.
Yeah.
I wanted to flip the Badri's question about the fear of AI. One, I want to make an observation that I think a lot of people don't make. I can bring in my professional background here as a computer guy and say computers aren't really doing computing or AI; they are simulating them.
Yeah.
Right. So that doesn't get through. Most people think computers are thinking, or they're not. They are simulating everything. So that I think that needs to be put across better. One, but question I had is I'll flip this fear of AI thing. What is the other side? You have we have seen recently of journalists and other celebrities spectacularly exposing their ignorance of even basic arithmetic. How does AI illiteracy among decision makers, or even computer literacy among bureaucrats, among the judiciary, government officials, how much of a risk is this for new kind of class divisions or a potential poor performance of these basic government or basic governance?
Yeah.
So is there any social aspect to it that any computer science department is dealing with?
Oh yes. So here is my summary slide, last line, right? The biggest danger from AI is humans rushing to market before technology is ready, and that is because there is enough impetus. Maybe decision makers say, "Why don't you use AI for doing this?" And then people come up with the AI solution without understanding what are the pitfalls, and this whole simple issue even of data bias and other things, right? And so this is serious problem. I'm not joking. I mean, in fact, I've been hearing all kinds of things even from the government about, say, why don't we use AI for this, why don't we do AI for that, and I mean, they have no idea of what is the effort involved and what are the pitfalls and so on and so forth. That's a huge danger for us, right? And there are organizations that are looking at the society and AI aspect of it. And I'm not exactly sure if there is anybody who is studying the effect of ignorance of AI on the part of decision makers. But there is a European study that is looking at how much of AI, how much of the AI information should be exposed to patients who are subjected to AI technology, at least in the healthcare sector. Right? So how much of the information can be hidden from the patient and how much should be exposed to the patient? So we are basically doing extensive surveys of both the medical side and also the technology side, and then they're trying to come up with some kind of recommendations. That's one study that I know of that looks at ignorance in this. But other than that, there are a lot of things that look at society, the social implications of adoption of AI, including our center. So we look at in the Indian context, we have concepts such as social justice, right? And anybody who is going to study fairness in AI is not really going to look at the Indian version of that, right? Indian version of fairness. So we really need to build mechanisms that can model those, right? So we have been looking at that, and we also have been looking at one ignorance study that we are doing is in the medical profession. We really want to know what are the expectations that people in the medical profession have of AI. What do doctors think? What do nurses think? What do hospital administrators think that AI can give to them? And what do, of course, patients think that AI is going to do? And what is the level of understanding of the impact of AI among people in the medical profession? Because a lot of new companies are coming up which are talking about AI in healthcare, diagnosis, and in general in the medical field. So that is one study that we have taken up internally here in IIT Madras, but I'm not sure of any other ignorance-related studies.
Thank you, Ravi. Wonderful. It was quite all-encompassing and a fascinating topic. There are more questions, but we have run out of time. And thank you for your patience in dealing with all the questions. And sorry about the fan and other
That's fine, that's
trouble
fine, that's
that
fine.
we've caused you. Thank you.
No, no.
And there are few,
That's fine. Yeah. I'm
there are
sorry
a few
about
more questions.
being not audible at the beginning.
No, it's okay. Thank you, thanks a lot, and thank you from Varahamira Science Forum. So we'll be back again next month with another talk, most likely also through YouTube until things get back to normalcy. Thank you once again. Bye bye.
You might want to
Thank you.
mention the Kutaka class for next week.
Oh, okay, fine. So I have been organizing. There was one batch of an algorithm teaching class. This is integral solutions to linear indeterminate equations in two variables, which is Aryabhata's Kutaka method. So I ran a workshop, and there is a second workshop coming up on the same topic. Next weekend, those interested, please get in touch with the organizers of Varahamira Science Forum, Ramki in particular. Thank you once again. Bye bye.